Good morning and welcome to NASA headquarters in Washington. My name is Dwayne Brown with the Office of Chairman. The journey to Mars just got a whole lot more fascinating. This morning, scientists will provide further details on the answer to a long-held mystery of the red planet and provide their thoughts and theories on the possibilities of what this could mean for life beyond Earth. We'll have short briefings and presentations by participants. Then we'll open it up for questions starting here in Washington, our phone lines, and social media. The information you will hear today and any other updates are available online at www.nasa/Mars. Also, nasa.gov, Journey to Mars. And of course, follow the conversation, and the conversation is phenomenal all over the world of what is happening and what will be talked about today. Social media. Lead scientist for the Mars Exploration Program, NASA headquarters. And ladies and gentlemen, joining us via phone from France, individuals attending the European Planetary Science Conference. Alfred McEwen, principal investigator for the High Resolution Imaging Science Experiment, or HiRISE, from the University of Arizona in Tucson. And Luigi Oja, of the Georgia Institute of Technology in Atlanta. And joining us from the West Coast, from NASA's Ames Research Center, is Mary Beth Wilhelm. Hold on to your seats and your hats, and I'll turn it over to John.
And not as interesting as we see it really is. Our instruments today are showing us a much more dynamic and complex planet, and one that is exciting for a number of reasons which I'll describe. And when we explore, we make discoveries, and that's really the human element. Discovery is why we do science. We're trying to answer fundamental questions about our universe, about our home planet, about our solar system. Questions like, where did we come from? Is one of the reasons why I feel it's even more imperative that we send astrobiologists and planetary scientists to Mars to explore the question of, is there current life on Mars? It's one of the things that I find most fascinating and excites me about coming to work every day. The way that we do that is to use our analytical instruments. And so these are somewhat complex measurements. And it is because we're trying to observe from orbit or observe from one spot on Mars that this is so difficult. But the more we observe Mars, the more information we're getting that it really is a fascinating planet. From the Curiosity rover, we now know that Mars once was a planet very much like Earth, with warm, salty seas, with freshwater lakes, probably snow-capped peaks and clouds and a water cycle, just like we're studying here on Earth with our Earth science satellites, the water cycle here on Earth. Answered by sending people, and I look forward to that day on our journey to Mars. The discovery we're going to talk about today really is most exciting because it suggests that it would be possible for there to be life today on Mars. And with that, I'm going to turn it over to Jim Green to describe a little more detail and background.
Thank you very much, John. You know, we're making enormous progress with our current orbiters and rovers, as John mentioned. And this is really to look at Mars because it is the planet that's most like the Earth. It is, of course, as we've talked about, the destination for human exploration going beyond Earth. If we go back perhaps 3 billion years and take a look at Mars, Mars was a very different planet. It had an extensive atmosphere. And in fact, it had what we believe was a huge ocean, perhaps as large as 2/3 of the northern hemisphere. And that ocean may have been as much as a mile deep. So Mars, indeed, 3 billion years ago, had extensive water resources. But something happened. Mars suffered a major climate change and lost its surface water. Today, we're revolutionizing our understanding of this planet.
Orbital evidence of the agent that had as a